The hunt for clean energy is it's full of hype. But every once in a while, a claim comes along that is so big, you just can't ignore it. So today, we're going to dig into some documents from a company that says it has found a way to produce hydrogen that could, well, fundamentally change everything. Let's see what the data actually says. So picture this. A clean fuel source that's not just a little bit better, but a staggering 50 times more efficient to produce than anything else on the entire planet. Yeah, that's the core claim we're exploring here. It sounds like straight-up science fiction, right? But one company says they have the patents, the machine, and most importantly, the data to prove it. And this is the machine right at the heart of it all. It's called the Hydrogen Production Unit, or HPU for short. Now, this thing didn't just appear overnight. It's the result of over 15 years of really intensive research by a company called Advanced Combustion Technologies, or ACT. And they believe this little unit represents a massive scientific breakthrough, one that challenges everything we thought we knew about getting hydrogen from water. So, how in the world does it work? Well, to really get what ACT is claiming, we first need to take a quick look at the century-old science they started with, and then we'll see where they basically threw the rulebook out the window. Okay, so the foundation for all of this is a process called electrolysis. You probably remember it from high school chemistry, right? You're basically just using electricity, like a tiny key, to unlock a water molecule, splitting it apart into its building blocks, hydrogen gas and oxygen gas. It's a super well understood process, but here's the catch. It's always been a massive energy hog. It takes a ton of power to get just a little bit of hydrogen. And this is where ACT's secret sauce comes in. They take that standard process and they supercharge it. So instead of simply passing a current through water, they create these incredibly high-energy controlled plasma arcs inside the solution, all guided by special nanoscale surfaces. I want you to think of it like a targeted lightning strike, but on a microscopic level. They claim this whole combination creates a hyper-efficient reaction that completely breaks the old rules about how much energy it should take to split water. Now, look, a claim this wild, you can't just take the company's word for it, right? The numbers have to be checked, and they have to be verified by an outside, totally impartial party. And that is exactly what went down in the spring of 2023. So ACT brought in a firm called North American Energy Resources, or NAER. They're an independent engineering firm, and their job was super simple, really. Watch the machine, meticulously record all the data, power in, gas out, and just report the cold, hard facts on its performance. So after running all their tests, monitoring every single watt of power going in and every liter of gas coming out, NAER came back with a number. A number that is, well, it's so low it's almost hard to wrap your head around. Less than 1. Let's be really clear about what that means, because this is huge. The independent report confirmed that the HPU created 1 kilogram of hydrogen using less than 1 kilowatt hour of electricity. This isn't just a small improvement. We're talking about an efficiency level that, according to the company, completely shatters known barriers in physics. Now, to put that result in perspective, ACT uses this number to describe their advantage: 50 times. Yep, that's their claim. A power consumption level 50 times lower than any other method out there. A leap this big doesn't just disrupt an industry, it pretty much creates a whole new one. But with a claim this big, you absolutely have to look at the fine print. Okay, so before we all start celebrating the dawn of the hydrogen age, we have to pump the brakes for a second and apply a serious reality check. Test results from a prototype in a lab, well, that's not the same as a commercial product out in the real world. So let's look closer at what that NAER report actually says. It's a question we should all be asking, right? The one you're probably thinking right now. Okay, so what's the catch? And thankfully, the independent report is super clear about the test conditions and what was, and maybe more importantly, what was not included. So the test focused only on the core reaction unit. It didn't include all the essential support gear you need for a full system, what engineers call the balance of plant. We're talking about all the other stuff: the control systems, the power supply, the equipment to cool and separate the gases, the pumps, the compressors. All of that extra gear needs power too. And this is crucial. NAER actually accounted for this. They crunched the numbers and estimated that a full, real-world system would probably use somewhere between 0.9 and 1.2 kilowatt hours per kilogram. Now, yeah, that's a bit higher than the raw test result, but it is still an absolutely game-changingly efficient number. And if that wasn't enough, here's the final twist. The report points out that because of a power supply issue they had, the prototype wasn't even running at its full designed capacity. It was basically operating with one hand tied behind its back. And in NAAR's professional opinion, if the system were running like it was supposed to, its efficiency should actually increase from what they measured. Wild. So if this technology is even close to what the data suggests, the impact goes way, way beyond just a single machine. It could totally reshape our entire energy grid, shifting us from the centralized model we have today to something completely different. So our current energy system is all built around these massive centralized power plants, kind of like you see there on the left. But ACT's vision, on the right, is the total opposite, a whole network of smaller, decentralized units that make hydrogen right where you need it. And man, the difference is night and day. The old centralized model means years of complex construction, and then you've got these huge challenges of storing and transporting a notoriously tricky gas. But the decentralized model that ACT is talking about, it's pretty much plug and play. You can roll these units out quickly with almost no need for storage or transport because you're making the fuel on site. This doesn't just change how we make power, it could change everything from trucking to manufacturing by putting the fuel source right next to the factory. And that whole transport issue, it's a way bigger deal than you might think, because the current system has a major leak problem, and the number you need to remember here is 17%. That's right. According to ACT's data, up to 17% of all hydrogen made in the big, centralized model is just lost. It leaks out during transport and storage. It just boils off. With a decentralized, on-site system, that entire loss is just gone. Boof. That's a huge efficiency gain before you even talk about how the hydrogen is made in the first place. Okay, we have the data, we have the mind-boggling implications. But that leaves us with one last, and maybe the most fascinating piece of this whole puzzle. The big question that even the experts who verify the results are asking. I'm just going to read this to you directly from the independent report's summary. Talking about the machine's insane efficiency, it says, quote, "We do not understand how this AXI process accomplishes this. The physical empirical data cannot be," end quote. I mean, just think about that for a second. The engineers who tested it, the ones who confirmed the numbers, are openly admitting they can't explain the science that makes it possible. And that's the incredible place this story leaves us. We have hard, empirical data from an independent source that says this machine works at a level that literally defies explanation. The data says yes. The science is a total mystery. So the question for all of us is, could this actually be the key to unlocking the future of energy?